All right, everyone, let's go ahead and let's get started with our first set of notes for plate tectonics. So create a new page in your science notebook, title it Plate Tectonics Notes 1, Finding the Age of Rocks Layer. Put a 1, 2, and 3 because we're going to learn about the 3 rules of aging rocks. So give yourself some space to write in. And then at the bottom of the page, give yourself some room to make some quick, important notes about fossils. And if you have any space left, any questions you may have. So go ahead and press play once you have that in. Okay, you do not need to write for this slide. What we're going to be talking about today is called the relative rock dating principles. Um, Geologists can tell the relative age of rocks. What we mean by relative age is figuring out what order the rocks go in from youngest to oldest. So which rock is younger, which rock is older. This is not going to tell us the exact age of the rocks, guys. I'm not going to be able to look at a rock layer and say, hey, this is 5 million years old. That's not what this kind of practice is for. This is just to help us put things in order from oldest to youngest. So example, think like I'm the middle child of 4. I have one older sister, a younger brother, and a younger sister. You don't know the exact ages, but you can put them in order from who is the oldest to who is the youngest just by that statement. This is where we're going to start writing. So there's going to be 3 principles, one for each of those numbers. Principle 1 is the law of horizontality. What this states is that all rocks are deposited horizontally at first. In other words, they're placed in flat. Think about like if you're pouring pancake batter on a pan. It starts off as one glob where you pour it into the pan, but then it spreads out into a nice flat layer. So that's our first rule, is that everything starts as a flat layer. Our next law is called the law of superposition. Our root word here is position, so this is about figuring where things lie in physical space. And this one's super simple, even though the name is really big. The oldest layers are at the bottom. The youngest layers are at the top. That's all you need to know for superposition. Oldest on the bottom, youngest at the top. Now, the next law is where things can get tricky because this is where it can start flipping some layers around and we have to figure out which orders they go in. And our third law is the law of cross-cutting. Anything that cuts through the rock must be younger than the rock it's cutting through. So for example, we have this cross-cut right here. We have our layers. We could figure out which one of those is oldest to youngest, but this cut is going to be the youngest thing because those rocks were placed first, then the cut came through. You can't have the cut without the rock layers, so that is the youngest piece. Just a little bit more detail on those things. One type of cut is called a fault line. It's a crack left over from an earthquake when the earth literally breaks. This will cause the layers to mismatch on each side. So that can be one clue to help you figure out that one has to be, the cut is younger because it had to have made those lines and layers mix up. And then a fault is always younger than the rock it cuts through. We've already talked about that. There's no need to write that down again. Another type of cut is called an intrusion. An intrusion is caused by magma, which is melted down rock, super hot. It's the stuff that comes out of volcanoes and then becomes lava. So magma that pushes through the other rock layers. Intrusions are going to be younger than the layers they cut through. Again, these rock layers came first, and then the lava came through and intruded into their space. And those are the 3 rules. If you can remember those 3 things, you can start putting some stuff in order. Now, there is one other thing that we use when we're trying to figure out the relative age of layers, and that's fossils. Now, fossils is a solidified form of a once living organism. Big emphasis on the solid piece. Now, usually these are like bones. When you go to the museum and you see the cool dinosaur skeletons, those have been preserved through a process called petrification, where the rock literally fused in with the bone and then turned it into a permanent rock that can be preserved for millions of years. Um, but there are a couple of other kinds of fossils out there. One is a cast, and this is the solidified shape of a fossil. So that would be like this thing down here on the right. That's like the 3D image of it left over. Another type is called a mold. And let's say that the cast got pushed down in some sand, um, and then for some reason it went away. It just broke down, it got moved, but the imprint was left in there. That would be called a mold. And just like with plaster, you could fill it in and you could get another cast out of it. Um, Another major type is called a trace fossil. These are fossils that showed up in the existence of a once living organism, like footprints, um, burrows from worms drilling in, and even poop. Poop can be fossilized, and actually, it's probably the most valuable type of fossil. It's a gross fact, but it is true. Okay, now that was just a little bit about fossils. This is how we actually use them to date the layers. There are these things called an index fossil. And what these do is that these are organisms that lived for a very short amount of time in Earth's history. And I mean a very short, specific amount of time. And they were widespread and then just disappeared. So, because they only lived in a short amount of time, they act as like a bookmark for different years or ages in planet Earth's history. And that can be very helpful to figure out how old a rock layer is, especially if you're looking at layers across the Earth. Now, the reason for that is this thing called extinction. And the reason why we don't see any index fossils except for specific pieces is extinction. And that's the end of a species. That species no longer exists. It cannot reappear. So, just like the dinosaurs, they cannot come back. We can debate Jurassic Park in class, but just take my word on this for now, guys. And that is a really sad picture. So, as you can see here, if we know that this fish here lived during a certain time period, we can match that up with different locations to say that those various layers are around the same age. So that's basically rock dating. I'm going to go through a couple of these layers, and I want you to get some practice in just putting these in different orders. I will post up the answer key to these in the classroom so you can check them when you come into class. But see if you can put these three layers in order and then press play to move on to the next one. All right, try these 5 now using those 3 rules. And then unpause it when you're ready to move on. All right, try these 3 layers next. And then press play when you're ready. And last but not least, try these ones, putting these in order from youngest at the top to oldest on the bottom somewhere on your page. And that's all the notes I've got. Go through to see if there's anything you missed, and I will see you in class.